Hi there. Welcome to one more video on the topic of creating and running threads. Hope you have been enjoying all the videos till now. In this video, we will see how to work with fixed thread pool executors. As discussed in the previous video, in fixed thread pool executor, the number of threads is fixed. In order to get an instance of fixed thread pool executor, you need to call new fixed thread pool method on a factory class called Executors. The number of threads that we need in the thread pool is passed as an argument to this method. I have already created a skeleton class called using fixed thread pool that has a public static void main method with a couple of sysouts signifying the start and end of the main thread. We also need one or more runnables that can be executed by the fixed thread pool executor. So before beginning to put some code in using fixed thread pool class, we are going to create a runnable implementation with a class called loop task A. Now loop task A will be used in some subsequent examples as well. So I am going to put it in a package named tutes.common to show that it is a common class used by many other classes and packages. As business logic of this task, I am going to use what we wrote previously for the threads API examples. So I am just going to do a copy paste here from the fourth way class. I am also going to put in here some sysouts with eye catchers for easy identification that will signal the start and end of the task. In order to emulate real-world tasks more closely, let us also make the delay random by making the tasks sleep for random periods rather than fixed periods of 200 milliseconds. For this, we can use the math.random method. This method returns a double value between 0.0 and 1.0. If we multiply it by 1000, we get values between 0.0 and 1000. Because the sleep method works with long value instead of double, we also need to cast this expression to long. So the task will now sleep for a random period that lies between 0 and 1000 milliseconds. And we are done with defining the task. There are no compilation errors. I hope it runs. Let's implement the main class now. First of all, we are going to create a fixed thread pool executor service here. like so. Keeping the number of threads in the pool as 3. Now this line that we have just added signifies the initialization phase of the executor service. On to the service phase now. Time to submit some tasks to this service. Now tasks can be submitted by using the execute method of the executor service interface. Let us submit 3 tasks to the service for the time being. Running this class now. From the output we see that all the 3 tasks had started simultaneously, as we had all the 3 thread pools available to execute them. A lot of context switching happens and each task gets a chance to run. So all the tasks run their course and in due time they all finish their business and end successfully. You can see that even though our tasks have finished, the program still has not finished. It is still showing this red icon here, meaning that the program is still running. Let me kill it forcefully by clicking on this icon. Now, why do you think the program did not end? Well, as discussed in the previous video, we need to carry out the destruction phase of the executor service by calling its shutdown method. Running it again now. Similar output, and our program has also ended. So never forget to shut down the executor service. Otherwise, it is going to cause a memory leak when you shut your application down. Moving on. Now, what if we submit more than 3 tasks? Let us try submitting 6 tasks. Running the program again. We see that only 3 of the tasks have started executing in the beginning. As soon as one of the tasks ends, another one starts. Here task 3 has finished and after that task 4 has started. Here task 2 has finished and then task 5 has started, and lastly task 1 finished and task 6 started. And afterwards tasks 4, 5 and 6 have also finished executing. But at all times, the total number of concurrently running tasks never exceeded 3. So what if we make the number of threads in the pool as 6? Let us try that. Running it again now. As you must have guessed already, all the 6 tasks have now started and are running concurrently. This is because now we had 6 threads available in the pool at the beginning itself. Now, what if we try to submit a task after the service has been shut down? Let us try that too. Running it now. We see that we have got a rejected execution exception on line number 25. This is as expected. As the service had already been shut down, it did not accept any new tasks for execution. One last thing for the newbies before we end this tutorial video. In this video, we have just submitted the same task multiple times for exploring the fixed thread pool. However, you can submit any number and any type of tasks that you want, and they may do entirely different things compared to each other. The same holds true for all the previous and subsequent videos in this course as well. So don't get confused on this point. This brings us to the end of this tutorial. See you in the next video now, where we will discuss cached thread pool executors. Till then, bye bye.